As we explore the solar system, we deploy robots to help us survey planetary bodies. To date, large teams on Earth have commanded robots on the Moon and Mars. However, an orbiting astronaut can communicate faster with a robot on the surface, leading to better teleoperation. The Surface Telerobotics experiment will study the way astronauts on the International Space Station remotely operate a rover on Earth across short time delays. The experiment scenario is the deployment of a telescope, conducted in 3 phases. The engineering data gathered from this experiment will help us to refine key system requirements and reduce risk for future human-robotic exploration. There are 3 phases in the experiment. The first phase is surveying and scouting. You will command the K-10 rover to scout terrain in order to find a suitable place to deploy the telescope. The rover will run pre-planned task sequences, but you will also need to help it adapt to contingencies by teleoperating it with single commands. The second phase is telescope deployment. You will monitor K-10 as it deploys the arms of the telescope by rolling a Kapton film out behind it. The third phase is inspection. You will assess the deployment of the telescope arms by obtaining oblique views of suspected flaws. At random intervals during rover operations, the experiment team will ask you to pause the rover and fill out a questionnaire. The questionnaire will be about your task load and situational awareness. Your responses will help us improve the system and the user experience. The Intelligent Robotics Group, or IRG, at NASA Ames Research Center directs the Surface Telerobotics experiment. We have 20 years of experience developing robotic systems for planetary surface missions. Our group builds and maintains the K-10 rover and software. During this experiment, we will monitor K-10 locally. Several subteams within IRG have contributed to this investigation. Our operations team designed the experiment, the phases, and the objectives, making sure all parts of the experiment come together. The rover team maintains the K-10 rover and wrote the rover software that supports all rover operations, including autonomous navigation. The Surface Telerobotics Workbench team designed and implemented the Workbench software, which will help you operate the rover by providing visualizations and controls. Multiple NASA centers have contributed to the Surface Telerobotics project. All of the communications between the rover and the workbench use NASA's robot messaging software, which was jointly developed by Ames Research Center, the Jet Propulsion Laboratory, and Johnson Space Center. Johnson Space Center will monitor the network and the network traffic and provide communication to the International Space Station. You will command and control the rover and the experiment through the Surface Telerobotics Workbench. Our K-10 rovers have been to numerous field sites on Earth, including Houghton Crater on Devon Island in Canada, Black Point Lava Flow in Arizona, and many sites in California. K-10 has 4-wheel drive, 4-wheel steering, and a passive averaging suspension. K-10 is powered by lithium-ion batteries and controlled by an onboard laptop computer that is equipped with wireless. The K-10 rover's navigational sensors include a GPS system, a digital compass, stereo cameras, and an inertial measurement unit. K-10 can be configured with different scientific instruments. For this experiment, it has a custom panoramic camera to image surrounding terrain, a rear-facing inspection camera to observe telescope deployment, a Velodyne LiDAR sensor to examine surface texture and assess terrain hazards, and a Kapton film deployer to position the arms of the simulated radio telescope. Astronaut participation in this experiment is central to our research into the best ways to operate rovers with humans. This experiment will be the first time that astronauts on the International Space Station will interact with a high-fidelity planetary rover in real time. The Intelligent Robotics Group highly values this novel use of our rover. Thank you for joining us in this experiment.